Chapter 5.1 is going to be the greatest common factor and factor by grouping. So now we're going to be getting into factoring. So this section is super important going forward. So greatest common factor and factor by grouping. So to start off, we need the definition of what a factor is. So to factor a number means to write it as a product of two or more numbers. So factors are things being multiplied. So the product is a factored form of the number. So factoring, in a sense, is a process which undoes multiplying. It kind of breaks it apart. So for example, we know that we can rewrite 45. So we're just starting with numbers for now, not any variables yet. We could rewrite 45 as 3 times 3 times 5. So if you multiplied all those together, you would get 45. So we would say that 3, 3, and 5 are factors, prime factors of 45. So the way that you can do this is kind of hopefully a refresher for prime factorization. If you're trying to figure out the factors, the prime factors, you can do it like a tree and think of two factors of 45. Well, we can say 5 times 9 is 45. 5 is prime, so I'm going to circle it. And then you think of factors of 9. 3 times 3 equals 9. Those are prime, so we're done. So that's how we know that 45 equals 3 times 3 times 5. Okay, so getting into the greatest common factor of integers, that should say greatest. So now we're going to be dealing with two or more integers and thinking about factors that they have in common. So if an integer is a factor of two or more integers, it's called a common factor of those integers. So for example, we know that 6 is a factor of 24 because 6 times 4 is 24. So 6 is a factor of 24. 6 is also a factor of 18 because 6 times 3 equals 18. That means 6 is a common factor of 24 and 18. They just share the same factor. So for the next thing, we have a greatest common factor, which we're going to call GCF. So the greatest common factor of integers is going to be the largest common factor of those integers. So 6 is the GCF of 24 and 18 because it is the largest of their common factors. So here are going to be the steps for finding the GCF of integers. So we're just still working with numbers, no variables yet. So I'll do this. You don't always have to do it this way, which I'll mention once we get to that point, but this is kind of the technical way of doing it. So steps for finding the GCF of integers, we're going to write each number in prime factored form, just like what I did with 45 up there at the top of the page. Step 2 is we're going to list the common prime factors that these two numbers have, and then we're going to multiply these prime factors together, and that will be the GCF. If there's no common prime factors, then the greatest common factor is going to be equal to 1. So let's do some examples to see what I mean here. So let's find the GCF, the greatest common factor, for 30 and 45. Okay, so on the side, I'm going to list out 30 in prime factored form, and then I'll list out 45 in prime factored form. So we already did 45. We said that was 3 times 3 times 5. If we did the same thing for 30, we would see that 30 equals 2 times 3 times 5. Okay, so I'll just do this one on the side, showing how I got that. 30, we can break it up as 2 times 15. 2 is prime. We can break up 15 as 3 times 5. 3 and 5 are prime. So that's how I got those numbers. So if you have to practice that for these examples. So now we look at the ones that they have in common. They have a 3 and a 5 in common. So that means the GCF for 30 and 45 is going to equal 3 times 5. We multiply them, which is 15. So the GCF between 30 and 45 is 15. It's the largest factor that they have in common. Next one, we have 72, 120, and 144. So if you have to practice doing that prime factorization that I just did with the little where it looks like a tree, feel free to practice that. So we're going to write down 72, 120, and 144 as a product of their prime factors. 72 Once again, practice this if you need to practice it first before watching it. We can write that as 2 times 2 times 2 times 3 times 3. So if we multiply that all together, we should end up getting 72. And they're all prime numbers, so we know that we're good. 120 we could write as 2 times 2 times 2 times 3 times 5. Once again, if we multiply that together, that would equal 120. And for 144, if we multiply 2 times 2 times 2 times 2 times 3 times 3, that should also give us 144, and those are all prime, so we would be good. So now we have to look at the ones that they have in common here. So all of them have 3 2's, and they all have a 3. So the GCF between those is going to be all of those numbers multiplied together. So that's 2 times 2 times 2 times 3, which is 8 times 3, which is 24. So 24 goes into, is a factor of 72, 120, and 144, and it's the largest factor they have in common. So next, let's do 10, 11, and 14. So 10 we can rewrite as 2 times 5. 11 is prime. So what that means is just straight up 11. You can write it as 11 times 1 if you want. I'm just going to write it as 11. 14 is 2 times 7. So these three have none in common other than 1. So the GCF here is going to be 1. So what we would say, what you could say for this is that if they have no common factor other than 1, you would say that these numbers are relatively prime to one another. So let's move on to doing it with variables now. So the greatest common factor when we have variables is going to be the variable with the smallest exponent. So let's do these examples. So find the greatest common factor for x to the 4th, x to the 5th, x to the 6th, x to the 7th. So the greatest common factor between them is going to be the variable with the smallest exponent, which is the x to the 4th. So the GCF is going to be x to the 4th. Okay, so relatively simple for these ones. So let's make it a little harder and do it with numbers also in it. So we have 21m to the 7th, 18m to the 6th, 45m to the 8th, and 24m to the 5th. So finding the GCF, do it to the numbers first. The GCF of 21, 18, 45, and 24. So take a second and maybe write it down how we did it in the other ones. It looks like the GCF of the numbers is going to be 3. And then the GCF of the variables is going to be m to the smallest exponent, so m to the 5th. So 3m to the 5th is the GCF of those 4 terms. Last one here, we have x to the 4th, y squared, x to the 7th, y to the 5th, x cubed, y to the 7th, and y to the 15th. So the GCF here, we take it one factor at a time. So looking at the x, that last term, y to the 15th, there's no x factor in there, so that's not going to be part of our GCF. So looking at the y factor, it's going to be the smallest exponent, which is the 2. So our GCF is just going to be y squared. So since an x was not a factor of the last term, it cannot be part of our GCF. Okay, so let's now get into factoring a polynomial using the greatest common factor. So we're going to be factoring a polynomial. So what we're going to be doing is writing a polynomial as a product of factors, where one of those factors is going to be the GCF. So we're going to be factoring the GCF out front. So I put that in quotes because that's not very mathematically accurate way of saying it. So that means we're going to be finding the GCF of all of the terms and essentially applying the distributive property in reverse. And we can always check our answer to make sure that it's correct by distributing afterwards and making sure we get what we started with. So let's go ahead and factor these using the greatest common factor. So we have 5y squared plus 10y. So that's going to equal, so we go one factor at a time, so we start with the numbers. The GCF of 5 and 10 is 5. The GCF of y squared and y, smallest exponent, that's going to be y. So we have to remember here to think about what we're left with. We're always going to, that's our GCF, the 5y. We always have to remember that we're dividing this out front. So the distributive property is multiplying, so the reverse direction of it, it would be dividing. So 5y squared divided by 5y, that's going to be left with a y for the first term, plus 10y divided by 5y, we're left with a 2. So I'm going to say, so that's our answer. It's factored, 5y times y plus 2. So I'll do a little check over here. So we're going to check this by distributing. So we're going to distribute. We end up getting 5y squared plus 10y, which is what we started with, so we know that we're good. Okay, next one, 20m to the 5th plus 10m to the 4th minus 15m cubed. So once again, let's do it with the numbers first, the coefficients. The GCF of 20, 10, and negative 15. It's just going to be a 5. So sometimes it's good to pull out a negative also to factor out a negative with it. In this case, I'm not going to. If the leading term is negative, that's when it tends to be a good idea to also factor out the negative. So the GCF of the variables is going to be m cubed because it's the smallest exponent. So dividing this out, we're going to get 4m squared from that first term. And then we're going to get, so remember when we're dividing m to the 5th divided by m cubed, we're subtracting the exponents, so we're left with m squared. 10 divided by 5 is 2, m to the 4th divided by m cubed is m. And then we're left with minus 3 for that last term. Okay, and then for next one, x to the 5th plus x cubed. So this is going to be a GCF of x cubed. And we're going to be left with x squared plus 1. So x to the 5th divided by x squared, x to the 5th divided by x cubed is x squared, and x cubed divided by x cubed is 1. And next one, 20m to the 7th p squared minus 36m cubed p to the 4th. So we have three different types of factors here. We have a coefficient, an m, and a p. So for the GCF of 20 and 36, looks like that's going to be 4. The GCF of m to the 7th and m cubed is going to be the smallest exponent, m cubed. GCF of p squared and p to the 4th is p squared, smallest exponent. And then we have to think about what's left over. So if we divide it out, 20 divided by 4 is 5. M to the 7th divided by m cubed is m to the 4th. So we're just subtracting these exponents. P squared divided by p squared is 1, so that is completely gone. The p factor is gone for that one. 36 divided by 4 is 9. M cubed is completely gone. And p to the 4th divided by p squared is p squared. So if you're never completely sure, just distribute and check your answer. Make sure you get what you started with. Okay, let's do a couple more here, and then we'll get into GCF, or grouping rather. So we have negative 8x to the 4th plus 16x cubed minus 4x squared. So this time I'm actually going to factor out a negative because it's on that leading term. It's on the term with the largest exponent. So I'm going to factor out a negative, and then it's going to be negative 4 because that's the GCF between 8, 16, and 4. And then the GCF with the variables is going to be x squared. And then when we think about what's left over, everything gets negated. So negative 8 divided by negative 4 is 2. So it's going to be 2x squared. And then 16 divided by negative 4 is negative 4. X cubed divided by x squared is x. Negative 4 divided by negative 4 is 1. X squared divided by x squared is 1. So we're left with plus 1 for the last term. Okay, for these next two, it looks a little more confusing. So we have a times a plus 3 plus 4 times a plus 3. So we have two terms here. We have this big term, and then we have this big term. So when we're looking at those two terms, the thing that they have in common is going to be the factors of the first term are a and a plus 3. The factors of the second term are 4 and a plus 3. So they have this a plus 3 in common. So I'm going to factor that out front with parentheses because it's a binomial this time. So it's two terms instead of one term. And then when we think about what we have left over, we have a plus 4 left over. So a plus 4. So that would be our answer for that one. So a little more confusing, so let's do another one. So we have x squared times x plus 1 minus 5 times x plus 1. Once again, we have two big terms. They both have an x plus 1. So that's going to be our GCF. And then we're left with, from the first big term, we're left with an x squared. Second one, we're left with negative 5, so minus 5. So that's that one in factored form using GCF. So it looks a little bit different with those ones, but it's the same concept. Okay, last thing here is going to be factor by grouping. So we won't always be able to factor out a GCF, but it should be something that you look for first. So keep in mind, always look for a GCF first. So if you can't do a GCF, the next thing that we should look for is factor by grouping. So kind of a hint here, which isn't the only thing that we can use grouping for by any means, which we'll see later on. Cubic polynomials, so degree 3 polynomials with all 4 terms, that's kind of a hint that maybe we can try grouping. So here's the steps for grouping. We're going to rewrite the polynomial in standard form, so we may need to reorder it. So standard form meaning decreasing order in terms of the exponents. We're going to group the first two terms together, and then we're going to group the last two terms together. We're going to factor out the GCF from both of those groups separately, and then factor out a GCF binomial, just like we did in the previous two examples. So let's see this using an example. So we have x cubed plus 4x squared plus 3x plus 12. There is no GCF here, right? So there's no GCF, so we can't do that. So what we're going to do is we're going to group the first two terms. So I'm going to group it with parentheses, plus group the second two terms with parentheses. Then we're going to factor out the GCF from the first group, which is x squared. We're going to be left with x plus 4. The GCF from the second group is 3, so we're going to group out or factor out a 3, and we're going to be left with x plus 4. So last step here, we have to factor out, just like the previous two problems that we did, we're going to factor out that x plus 4 because it's common to both of them, both of those big terms. And then we're going to be left with x squared plus 3. And that's going to be the answer for grouping. For this one, factoring by grouping. So another one, we have 5x squared plus x cubed minus 2x minus 10. So we have to rewrite this as x cubed plus 5x squared. So I'm rearranging it in standard form. I'm going to group these two together. I'll actually group those together in the next one. And then it's going to be minus 2x minus 10. So all I did was rearrange, put it in standard form. So now I'm going to group this. So x cubed plus 5x squared. Since the next term is a minus, what we have to do is do plus and then negative 2x minus 10. So that's something to keep in mind. That's super important for these ones. Because if you put a parenthesis after the negative, then it's technically changing the last term, because the negative means it would be being distributed. So factoring out the GCF of the first one is going to be x squared. We're left with x plus 5. We want to factor out a negative 2 for the next one, because if we factor out a negative 2, that means we're left with x plus 5. So you always want to factor out whatever you have to in the second one to get the same thing as that first one. So now we can factor out the x plus 5, and we're left with x squared minus 2. So that would be our answer for that one. Okay, and then for this last one, the last one's a little bit harder here because we have x and y. So let's just kind of give it a shot and see what happens using the same method that we're just doing. So let's group those first terms together. 2x squared minus 10x. And it's plus for the next one, so we don't have to worry about adjusting that. Plus 3xy minus 15y. So factoring out the GCF from that first group is going to be 2x. We're left with x minus 5. GCF of the second group is going to be 3y. That's going to mean that we're left with x minus 5, which we know that that's what we wanted because that's what the first one was here. So now we can factor out the x minus 5, and we're left with that 2x plus 3y. Okay, so that's it for section 5.1. That's factoring using the greatest common factor and also factoring by grouping.